Hey everybody, hope you're ready. In this example, we will find the exact value by using a sum or difference identity. And we're going to start here with tangent of 13 pi over 12. If you're going to be asked to do this on a test or a quiz, assessment, assignment, anything, your radian angle measures are likely going to have 12 as the denominator, especially in a situation where you're expected to find an exact value, meaning you're not touching a calculator. And on top of that, you're not supplied with any additional information. Sometimes you could be given other information about certain triangles, and we won't be talking about any special types of angles like multiples of 30 or 45 or pi over 6, pi over 4. So look for those pi over 12s. So I like to do this using some identity, but I will show you this two different ways, because if you don't rationalize your denominator, you will get answers that look different but are actually the same. So let's get into it. So here we have tan of 13 pi over 12. Now, what I like to do is I always make one of my angles pi over 4. The formula that most people will know or recognize will be something that looks like tan of alpha plus beta, a plus b, x plus y, something along those lines. They're just variables representing two different angles. Whenever we have an angle like this, 13 pi over 12, the reason it's worth doing this way is because it doesn't land on the unit circle that we're used to. It is basically going to fall in that little pocket right between the x or y axis and the angle right off of it. So the pi over 3s or the pi over 6s, these are like 15 degrees, 75 degrees, and so on. So since they're not on the circle, but we can create them using a sum or a difference of angles that are on the circle, one of those angles, in order for it to not also be on the circle, has to be 45 degrees or pi over 4. Just start there. Start with that. Start with that, okay? The other nice thing about starting with pi over 4 is the tan or tangent of pi over 4 is 1, and you don't have to worry about that one being positive or negative. It's just 1, and you're good to go. So what am I going to do here? I'm going to start off by making my first angle alpha, which I'll mark it here, pi over 4. However, I'm not going to write pi over 4. I'm going to write 3 pi over 12, because in order for me to add or subtract two angles and get a sum or a difference with 12 in the denominator, that's how I need to consider my angles, right? So 3 pi over 12 is going to be one of them. Now, what amount should I add to 3 pi over 12 to get 13 pi over 12? So that would obviously, hopefully obviously be 10 pi over 12. So that right there is my beta. So beta equals, now on this side, I'm going to write 10 pi over 12, but in between, I'm going to acknowledge the reduced, more familiar version of 10 pi over 12, which is good old 5 pi over 6. Now, the formula that I want to use for angle sum identity for tangent is as follows. It is, just going to shrink this out of our way a bit. It is going to be the tan of alpha plus the tan of beta, a little blurry, we'll fix that in a second, over 1. Now on the denominator, if this is plus, my numerator is plus, the denominator will be the opposite sign. So in this situation, the denominator is going to have a minus sign. So minus the product of tan alpha, tan beta. So that's the formula I'm going to be referring to. And I'm not going to write it as 3 pi over 12 and 10 pi over 12, but I am going to write it as pi over 4 and 5 pi over 6, because that's what I'm comfortable with. What do we got? Tan pi over 4, which we said is 1, plus, so we're thinking ahead, you know, tan of 5 pi over 6. If you've memorized the tangent values the way I have, I know that tangent of all angles over 6 are root 3 over 3. And I think to myself, 3 plus 3 is 6. 3 makes 6. So root 3 over 3. Root 3 over 3. 2 3's make a 6. Tan of anything over 6, root 3 over 3. all right? And we'll talk about the other one later. But 5 pi over 6 is in quadrant 2. It's right before the pi, or 6 pi over 6 pi. So quadrant 2 and tangent is negative in that quadrant because you have a positive opposite and a negative adjacent. So opposite over adjacent, positive over a negative. We'll get to that in a minute. 1 minus, and then the product of those two things as well. Now, weird things that everyone does, and I didn't mean to write B, weird things that people do that make me sad. Angle sum tangent addition, or really angle sum identity addition, is that when you guys are writing down the answers for the tan of whatever angle, or the sine or the cosine, depending what you're doing, you guys evaluate it, but you leave tan there. That's weird. That's like saying the square root of 100 equals square root of 10. Why are you keeping the square root there? You already took the square root, you know? So the square root is like the tan. It's an operation that you're applying. Once you apply it, you don't write it anymore. That's weird. Okay, don't be weird. It would just be 10 and you're done. So we'll make sure we address that as well. And if you're one of those people, now you know why your teacher thinks you're weird. I'm just kidding, kind of. Now let's go ahead. Next step, tan of 1, listen to me. Tan of pi is 1. We said just know it, it's positive 1. Tan of 45 degrees, tan of pi over 4 radians, whatever. Plus, now I'm going to be a bit doofy. I'm going to write it all out just for, understanding's sake. This is plus negative root 3 over 3. I would never normally write plus minus, plus negative on a piece of paper. I think that that's babyish. Just saying it like it is. Saying it like I see it. Over 1 minus, I also think this is ridiculous, 1 times something right now, and negative root 3 over 3. But why am I pointing it out? Because you guys do weird things. People will be like, oh, 1 minus 1, 0. The bottom 0, it's undefined. Oh man, guys, properties of exponents, order of operations, been a thing forever, right? You got to do this first. So what should this look like in the next step? 1 minus root 3 over 3. I would probably write this whole thing down initially, right? Over 1, that's negative root 3 over 3, and minus negative is plus. So plus root 3 over 3. When you're doing tan of an angle over 12, your numerator and denominator are going to look quite alike if you do it the right way, but there will definitely be, and if you use pi over 4, the ones are going to even match, but you'll definitely have different signs on top and bottom. They can't be the same. If you have something over itself that equals 1, that means that that angle is landing in quadrant 1 or quadrant 3 and has a 4 as its denominator. So you're confused if you're getting matching numerator and denominator. That's strange, okay? So that's pretty cute, I guess, but that's, kind of gross. So first thing we want to do is we want to get rid of the compound fraction. Whenever I have compound fractions like this, I like to call it, I make my hamburger, I have a bun on top and I have a bun on bottom. And what I'm going to do is I'm going to multiply through on top and on bottom by the lowest common denominator of the 1 and root 3 over 3 in this case. The lowest common denominator in this situation would be, if you said 1, you're a very silly goose. It's 3. Don't get confused by the word lowest. And you're going to distribute that through. So if that gets multiplied in, the 1 becomes 3, right? Please don't say 3 root 3 over 3 for this next part. Again, babyish. Don't do that. The 3's cross out. You're allowed to multiply and divide, just like you're allowed to divide and then multiply. They're the same operation. PEMDAS is sort of a lie. Root 3's cross out, root 3 is left. Minus root 3 over, same idea, 3 plus root 3. Now, that's better. Not great. I've seen people that think that, it's fine to leave that as the answer, but not loving it, and I'm going to show you why I'm not loving it. So we're going to pause this one, and I'm just going to flip over to a clean page for just a second. So let's keep in mind what we just did here. I ended up using pi over 4 and an angle over 6. Anytime you're incorporating an angle with 6 in the denominator, you'll have these two 3's, you'll have a complex fraction, and then you're going to end up in the same situation. Okay, it's just, this is how things go. What if we went the other way? What if I found an angle larger than 13 pi over 12 and subtracted to get to 13 pi over 12? So let's take a little peek. So I'm going to jump over here. Tan of, I'm going to use the subtraction. I'm going to have this pi over 4 as my secondary, angle, my beta. But what will I have to subtract? So let's look on the side. Alpha minus beta is what I am working with. If my beta is pi over 4, which I'm thinking of as 3 pi over 12, what would I need to subtract 3 pi over 12 from to get 13 pi over 12 as my answer? Hopefully, we've all said 16 pi over 12 by now. Now I'm going to reduce both of these. Divide by 4 on top and bottom. That's what? 4 pi over 3. Aha. And using 3 is actually a little cuter in this case. And minus pi over 4. So earlier I said how alpha, anytime it's over 6, root 3 over 3, root 3 over 3, root 3 over 3. It takes two 3's to make 6. If it's tangent of an angle over 3, also make sure it's reduced. If it's tangent of an angle over 3, it's just root 3, and then you decide if it's positive or negative. Tan of anything over 4, plus or minus 1. Tan of anything over 3, positive or negative, root 3. Tan of anything over 6, positive or negative, root 3 over 3. Got it? Get it? You got it. So that's where we are now. Alpha, beta, now we apply the sum or difference identity formula. Tangent of 4 pi over 3 minus top sign matches. Tangent of pi over 4 over 1 opposite sign plus the product. Tan of 4 pi over 3 and tan of pi over 4. Now, where is 4 pi over 3? Give it a little thought. That right there is 3 pi over 3. 4, 5, 6 pi over 3. So here we are in quadrant 3. Tangent in quadrant 3 is positive. Positive, negative, positive, negative. Your opposite and your adjacent are both negative. Opposite over adjacent becomes positive. Makes sense. So this guy right here is going to be root 3 minus, we said this is 1 over 1 plus root 3 times 1, right? We talked about this. It's just root 3. Now, what did we just have on the other page? Well, we had this. 3 minus root 3 over 3 plus root 3. Well, 3 minus root 3 over 3 plus root 3. Do you believe this? Do you believe that those are the same answer? If you got this, but this was the only choice on a multiple choice test, would you feel comfortable picking that? Let's talk about rationalizing. If I rationalize my denominators, and you've learned to rationalize denominators since geometry. Rationalizing denominators in trigonometry is honestly one of the most important places to rationalize your denominators. There are even still calculators out there that people have access to and use that will not compute the trig inverse of a ratio with a radical in your denominator. And here is a different type of scenario why rationalizing our denominators is important. We can have two very simplified answers, aside from being not rationalized, that don't look alike. They don't look the same. And it's almost unbelievable to think that they are the same. Now, how do you rationalize a denominator that has a radical as a part of a binomial sum or difference? Hopefully everybody remembers that you multiply by the conjugate of the denominator on top and bottom because you have to multiply by 1. So let's look at that. If I do that over here, I'm just going to do some silly little messy scrap work, so bear with me, okay? The conjugate of this denominator is 1 minus root 3. And anything you do to the bottom, you're going to do on top, because anything over itself is 1. 1 is the multiplicative identity. Go us. What about here? 3 minus root 3. Conjugate, same beginning, change up the ending. So we'll do that there. So big question mark, are they equal? I'm telling you right now, they are, but let's verify and see how so. You're welcome. The way you multiply binomials by multiply a binomial times another binomial is you have to use distribution or FOIL. Okay, stop trying to take a shortcut. You're wrong. It's not right. It's not right. Just stop doing it. I don't know why. Like, I know you were told it was wrong already, yet you keep doing it. Like, you're like, this is a shortcut. I'm going to do this. It's faster. It's also faster to wrong. So stop doing it. Thanks. We're going to use FOIL, first, outer, inner, last, right? So root 3 times 1 is root 3. Outer, radical 3 and radical 3 is 3. Radical 9. And it's negative, so minus 3. Inner, 1 times 1 is 1, negative 1. Last times last, negative times negative is positive. 1 times root 3 is root 3, so plus root 3. That's my numerator right over here. Over, on bottom, when you multiply conjugates together, the outer and the inner will always cancel out. Cancel becomes 0. First times first, last times last is all that matters. This is intentional. We do this on purpose. This is how we guarantee we will not have a radical in the denominator anymore. 1 times 1 is 1. Outer was negative root 3 when you multiplied. Inner was positive root 3. Nobody has time for this. Let's keep it moving. Last times last is negative. Positive times negative. Root 3 times root 3, root 9, which is 3. Don't be a weenie and keep saying root 9. You got this. It's 3. We've done this for years. Now, clean that up just a smidge, just a hair. Root 3 plus root 3 on top is 2 root 3. Negative 3, negative 1 is minus 4, negative 4. That's not under the radical. All over negative 2, and a little pretzel style division reducing. This right here will become negative 1 root 3 or negative root 3. And this will become positive 2. So that is the answer on the left. I know I'm making a mess. That's why you watch, listen, follow along, right? Now we're going to do the one on the right, and it should work very similarly, right? First times first on top, we get 9. Outer, 3 times negative root 3 is minus 3 root 3. I'm skipping steps this time, so come along on the journey, okay? Negative 3 root 3. Inner is also negative 3 root 3. Maybe I should write this down. I'm going to write this down. Negative 3 root 3 minus another 3 root 3. You're subtracting 2 of the same thing. That is not canceling out. Don't do that anymore. You are grown now. You will stop doing that, right? And then last times last is negative root 3 times negative root 3 is positive. Say it with me. 3. We're so good. Over. Bottom. We talked about this. They're conjugates. Only need first, last, last. First is 9. Outer, inner, by. Last times last is minus 3. 9 and 3 is 12. Negative 3 root 3 minus another 3 root 3. Please remember that adding and subtracting is counting. You are counting something. In this case, I'm counting root 3s. Negative 3 root 3, negative 3 root 3 is negative 6 root 3. You don't touch the root 3. That's the thing you're counting. Adding and subtracting is counting. So minus 6 root 3 all over 6. Reduce this pretzel style. 12 over 6. Interesting, it's 2. Negative 6 over 6 is negative or negative 1, and the root 3 stays. Oh my gosh, check us out. So verified that they are, in fact, the same. So what did we learn from this? Couple things. 1, rationalizing denominators is important. 2, anytime you're dealing with angles over 12 and are being expected to use angle sum or difference identities, make one of your angles pi over 4, but with the common denominator 3 pi over 12. What else are you learning from this? Depending which route you take with any tangent example, you can end up with one of two answers if you are using a tangent identity, whether it's sum or difference, and they will look different. And to get them to look the same, you want to rationalize your denominators, and we do that by using conjugates. I'm very sorry this turned into a 20-minute video, but I just thought it was very important that I clarify all of this for all of you little geniuses. I hope you feel so strong and powerful in the trig world right now, because if you're taking any type of pre-calculus, this is probably going to be on your test, quiz, midterm. It's there. Maybe a different angle. It's there. Okay? So good luck. Watch it again if you have to. Put it in double speed. Thumbs up if you got this and you feel good, smart, enlightened. Thumbs down if you hate it. Hate everything. Hate me. Hate math. I don't care. Not offended. And I will be adding a bunch of videos to this playlist. Probably like 95 videos. So check back in for more. Or go to the beginning if you're at the end of the list, and good luck. Adios.